What are the x-coordinates of the relative extrema? It might be easier to sketch the graph first, but we should be able to answer these questions with just the table. So let's answer the questions. Relative extrema would be where f prime changes signs. So let's see, a max would be where f prime changes from positive to negative. That would be at x equals -1 and nowhere else. And there's a minimum where f prime changes negative to positive, but that doesn't happen. So the only thing we have is a relative max at x equals -1. There is another horizontal tangent line, but it's decreasing on the left and decreasing on the right. So that's one of those places where it's going down, straightens out, and keeps going down. So there's not a maximum in there. What are the x-coordinates for all the points of inflection? Well, point of inflection is where f double prime changes signs. It doesn't matter which direction it changes, positive to negative or negative to positive. So it changes at, so the second derivative changes at x equals 0, negative to positive, and x equals 1, positive to negative. And now I want to sketch a graph of this thing. So it looks like the 1s and the 3s are the only sort of points that matter to the graph. Thank you. So from -3 to -1, we want to be positive first derivative, negative second derivative. So for f, that means we are increasing but concave down. I mean, I don't have to add a third row to this column, but maybe it helps me think about what's going on. So increasing but concave down. So something like that. When we get to -1, we're flattened out, but we're concave down. That fits with the next two pieces, or the next interval. From -1 to 0, we are decreasing and concave down. Yes. At 0, we're still decreasing, but we have a point of concavity. From 0 to 1, we're decreasing but concave up. And then, I sort of already sketched the rest of it. It's flat, and then decreasing, concave down. I guess what's tricky is I don't have any y values to sort of attach this to, so where this is up and down is not going to matter. So from -3 to 1, we are increasing. At -1, we reach a maximum, something like that. From -1 to 0, we're decreasing and concave down. At 0, there's a point of inflection. So something like that. We're still decreasing, but we switched from being concave up to being concave down. And from at 1, we have another point of inflection, but we're still decreasing, so we're going to switch over again and then be concave down and decreasing the rest of the way. So something like that. Now it doesn't have to be there. You could have drawn the same picture way down here. Because we didn't have any y values to attach it to. The graph of a function, together with some points on the graph, is shown below. So this is f of x. That's not the derivative. That is f of x. At which point is the first derivative of f of x positive? Well, f prime is positive when f is increasing. So f is increasing at a and at d. At which point is the second derivative of f of x positive? Second derivative is positive when f is concave up. So concave up, not A, not B. C is iffy. I guess you could say C or you could say not C. I'd be okay either way. It's not really clear if we've had the point of inflection yet or not. But definitely D. So C question mark, but definitely D.
So why wouldn't it be B as considered positive?
Because at B, I mean, again, I don't know exactly where this point of concavity is, but if it's right there, B is bowled down. Its slopes are decreasing. They're becoming more negative. I mean, there's your pictures of concave down and concave up. It's a little tricky because f prime could be positive or negative. F prime could be negative or positive, but that's different from concavity. Let's do 5 real quick, because 5 is, I mean, I can almost guarantee it'll be something like 5 on the AP test, because I just love to give you a picture of f prime and then ask some questions about it. The graph below is the graph of the first derivative of a function. So that's the derivative. Use the graph to answer the following questions about f on the interval from 0 to 10, but we're not including 0 and 10, so we may have to be careful about that. Part A, on what subinterval is f increasing? Well, before I look at the graph is f prime. So what am I looking for on f prime if f is increasing? When what's positive? When f prime is positive. When f prime is positive, f is increasing. So f prime is positive from 2 to 6 and 8 to 10. Because this is the graph of f prime, and I'm looking for where the graph is positive. On what subintervals is f decreasing? Well, that would be where f prime is negative. F prime is negative from 0 to 2 and 6 to 8. Find the x-coordinates of the relative minima. Relative minimum occur where, what, in terms of f prime? How do I find relative minimum if I know f prime? Yeah, well, which one for minimum? For minima? Negative to positive. So now I look on my picture of f prime, and I want to know where this graph changes from negative to positive. That would be at x equals where this graph goes from being below the axis to above the axis, 2 and 8. Part D, find the x-coordinates of all relative maxima. So that would be where f prime changes positive to negative. So where my picture is f prime, my picture changes from positive to negative at where? X equals 6. And I think that's all I can say. I mean, x equals 10 maybe, but x equals 10 isn't part of the function anyway because we're not including 10. And we don't know what happens after 10, so I don't want to include 10. On what subinterval is f concave up? So again, I want to rephrase this question in terms of f prime because I have a graph of f prime. So say something about concave up relative to f prime. What am I looking for? How do I know we're concave up? What's that? Well, concave up looks like that, but that's where f looks like that. I want to know something about f prime, where f prime is increasing. F prime is increasing. My graph is going up from 0 to, I'm not sure what point that is. 3.5, 4, 3.8, I don't know, whatever you want to call that. That's one of those where I'd accept anything. I would know what you're looking at there. Somewhere in there. F prime changes from increasing to decreasing. I definitely do not want to include 0 in that. In fact, for increasing, decreasing, and concavity, generally you don't want to include any of the endpoints. And then again, f prime is increasing from 7 to 9. F is concave down when f prime is decreasing. So that would be whatever point we said that was, 3.8 to 7, and 9 to 10. So looking at a graph of f prime and making some conclusions about f. Be careful. Basically, the best way I think is to rephrase the question in terms of what you know. You know f prime, so restate the question in terms of f prime, and then start looking at the graph.